Hi Sami, thank you for coming today and talking with me about Secure Shell and all these lovely things that you've been doing for such a long time.
Thanks for having me. I really started working with the Secure Shell stuff when I started work as a summer trainee in SSH.
And that was
98.
98.
Yeah.
So,
But I did use Secure Shell before that because I remember that I was like thinking that is this connected in any way with the thing that I was using in the university?
oh, so you didn't know when you joined SSH?
I was like that there's the same name.
Ah, okay. Okay, so it was already the best kept secret in cybersecurity
pretty
that
much.
it's a Finnish
Yeah.
invention and company. Yeah, that's pretty neat.
Yeah. So I was interviewed as a summer trainee or for summer trainee position by Samuli Mattila, and at that point he told me that okay, we are doing this Secure Shell stuff. But the company had already pivoted to IPsec and nobody was actually working with Secure Shell other than the contractual stuff necessary. And then I started to work on that.
Right. So you were pretty instrumental with a couple of the RFCs that are Secure Shell related.
Quite minor contributions in the sense that I was just I was quite junior at the time, but of course I was doing the code, implementing some of the stuff with Timo Rinne and others. So back in the day.
But you went to IETF.
Your
name is on a lot of those RFCs.
Yeah, I was RFC editor for quite some time also.
Yeah.
So there was some back in those days there was this nice copyright thing going on and with the name, and that caused some if that hadn't happened, I would probably have been the RFC editor to the end. But as it is.
Yeah. Politics got involved.
Politics got involved, yeah.
There has been some talk lately that there could be Secure Shell 3 protocol. Do you see any use case for that?
If it simplifies stuff, maybe. But as if it's incompatible with SSH2, I don't know. Why would you?
Yeah, it's more based on the quick logic that they're doing on TLS, so a similar thing.
Yeah, I just the use cases for where I'm working in IoT stuff now, and there's some cases where you want to have reverse login to login to the devices, but it's not you don't do it at scale. So you don't take remote terminals to the devices by and large, unless you are Chinese. But the thing is that you don't need the that kind of scaling in that. So I don't really for those use cases. I don't see the need because it's mostly the file transfers and such. They are happening over HTTPS, and there's new standards coming with the Quick and other things. But I don't know. Maybe if there's some very interesting use case that gets handled, then maybe. But I don't see it right now.
Well, in the IETF, they're trying to get the old stuff sorted out, finally making SFTP a proper standard and all that, cleaning up sort of maintenance sort of things happening. But I think from my point of view, the Secure Shell 3 protocol probably it wouldn't add so much benefits that when it would be incompatible with the SSH2 protocol.
Yeah, I'd see that.
There's let's put it this way, if you could go back now, knowing all the things that you know, are there some stuff in the protocol that you would change in retrospect, even though we probably would do some things slightly differently, but then probably doesn't warrant like a whole new protocol at this stage, but if you had a redo, is there some parts of it that you would think differently now?
Yeah, well, the most of the like bigger like these like problems there, we had like these attacks that were against the use cases that we had, and it's like when to start encryption versus taking digests of the messages. So encrypt in MAC and MAC then encrypt this kind of stuff. So encrypt then MAC is like right now had some issues in TLS cipher suit modes, but back in the day, MAC then encrypt was causing problems because of it was used as this kind of oracle to like see if the if you actually pass the like encryption layer, and you can like cause like a leakage of bits from key material, and we needed to do some like really interesting hacks to like get rid of that problem because the length field, you could use that as a like oracle, and very like nasty thing. But like besides that, there's the algorithm agility, which is like in one hand it's nice, but on the other hand it's like complicates the like initial handshake quite a bit.
Yeah,
so
right now it has been lovely because we have been able to do the post-quantum cryptographic hybrid algorithms, because the Secure Shell protocol was sort of designed that you could do these things. They're not so tied together as cipher suites as the TLS ones are. And
it's like I'm a little bit like on the fence on that issue, because you can always like when you start to do algorithm agility, you need to release a new software version anyway. So like you can just like add that bit to the handshake at that point anyway, because you are not going to like you don't want to release software that you haven't really tested. So having like this kind of open-ended library compatibility with whatever, it's not like I don't think that it ever really works. So
yeah, I mean, crypto agility is such a broad term used for many different things, but I guess like for me it's that the versatility of the protocol itself, that you can negotiate these things and you can add custom extensions if you want to do things that are not yet standards. I mean, we had to do it with the SHA-1 to SHA-2 transition. The same thing now with the PQC algorithms. But there is certain complexity. I think like part of it is like you could negotiate the different directions, like different ciphers and different other algorithms used, like client to server and server to client. I don't know any implementations that would actually use that. I would probably get rid of the non-ciphers and other things that are in the standards that are not, like, they're great for troubleshooting situations, maybe. Like,
not really. Like I have never had a use case where the non-algorithms would have actually solved anything. So it's like it was always like with the added debugging. In
well, so we had to use our crypto auditor product at some point to look into stuff with some third-party things, the way they were doing stuff.
But you wouldn't use
but
the
that's
none.
Like but you wouldn't use the none. I mean, you use crypto auditor for that. But
you have attacker in the middle in that case. But in many cases, it's just like an again added attack surface. Like all of those kind of like unused options should be gotten rid of. That's my de jure opinion. If you are not like really using it, it's better to get rid of it, because it tends to just bite you. So it's not like well, okay. Sometimes it's nice to have those like backstops for troubleshooting, but non-ciphers, for example, we never use them for that, because it's just too doesn't like usually doesn't help, because you are not interested in the raw protocol layer happenings, but you need to see what software is actually thinking. So then you need to debugging, like troubleshooting happens by syslog.
Yeah.
So
you mentioned the OT side of things. Like, what's the biggest difference or the kind of lessons learned from the IT side that you're very well familiar with, that you then were able to take the lessons to the OT side? I guess like my understanding of the OT is always it's safety first, and it kind of flips the ideology on its head. But
yeah, so there's definitely that. So like this accessibility of the functionality comes before the security many times. It's like much more important that the stuff works. Like this kind of like straight up OT, I haven't been doing like this like factory controller systems and such, but in the human transport level of things, there's similar things in the protocol level, and it's really like we just don't want to disrupt the people flow. So it's that's the more important thing. But of course, security is like very close behind that, because it tends to, like, if you don't have good security, you don't have like DOS resistance and other things. So it's very soon you need to do stuff securely, because otherwise it's like going to cause problems from the other point of view. So okay, somebody can deny your connections, but they can deny them by DOSing or other attacks. So this kind of strong authentication of devices to each other, that's very important, and the industry is moving to that. With different standards are actually enforcing encryption in many places. Like all the external interfaces need to be secured somehow, and typically the good idea is to secure them with the existing protocols like TLS and SSH. More TLS in the like these when you have like an application protocol over it, it's much easier to do it. Like, well, not much easier, but let's say that the library support in different embedded environments and etc. It's like TLS has like a longer this kind of support for like you doing the things over it than Secure Shell, because Secure Shell is for this kind of administrative things.
Yeah, and file transfers and things.
Yeah.
There's a little bit of those tunneling use cases still, especially now with the quantum safe tunnels. But they in some ways they try to solve the same problem, but they have rather different approach. Like in Secure Shell, it's very important the user authentication of it is like really the big beef of Secure Shell, whereas in TLS you tend to offload the device or the user authentication to something else. And TLS just does the server authentication and the encryption.
Yeah, in the use cases that I've been working on, that's that's the thing. But in IoT, you don't like typically you are not talking about the end user authenticating to anything. The devices are discussing amongst themselves, and there you can use like a mutual TLS authentication. So you just have like certificates typically, or some other means, but basically certificates are the way to go. And with the IDEV, that is this year standard about what was it, 802.1a or something like that. There's like this like infinite-lived certificates that have like device support for secure storing of the private key. Those are like now the rage to use those, because they reduce the key like management from those devices, because you only need to do the enroll the certificate at the factory and then you're good to go.
What do you think is the most pressing cybersecurity problem right now?
Buggy software. It's been like that like since we got the good algorithms there, and after that it's been buggy software, and it's going to be buggy software. Like I don't see any other. Like algorithms are like we need to have like good algorithms so that they are not like broken out of the box, but all the 0 days are buggy software, and they will be buggy software from now till I perish.
Yeah. So is there some either customer story without naming any names or some other story from back in the day that was sort of like interesting thing or?
Well, there's probably many. I hadn't like thought of any specifics. Well, we had this nice interaction in the pre-2000s. Me and Kivinen went to Americas because all the salespeople were like climbing the walls because the big customer was not so happy with the things, and well, we went to the site, and like I was helping the customer with the Windows side of things, and Kivinen was helping with the AIX side of things, and it was basically okay. We had a couple of software issues there, but mostly it was just that the customer was using this kind of like file transfer. They didn't know how to do it, so they were using the terminal scrollback buffer to copy paste device logs to Word.
Oh, okay.
So that was how they were storing their logs from the actual servers that they were using, and they were unhappy that our scrollback buffer was 10,000 lines maximum. So they were like coming to our sales that you need to fix this, that it needs to be like unlimited scrollback buffer, and we were like, why? And then we went to the well, we had first our salesperson was offering lunches to the customer, and the end of the week the customer was giving lunches to us. So it was a very nice visit. There was like a little bit tension at the start.
I assume the solution was secure file transfer.
Yes,
protocol.
it was. Yeah. So I was like that. You have this button. There's a folder icon in the upper right corner, so you can click that and like drag the log file to your desktop, and you don't need to copy paste like by hand. And it was like faster for the customer, and it was retaining the log cohesion, and like you didn't need to I don't know how big the file size was after copying it to Word, but I assume quite a bit. So they got smaller transfers and more convenience to the user. So that was like a win-win-win.
Yeah.
And on top of that, they were very happy to get introduced with this file transfer functionality that was novel to them. They didn't know that they were using they had like some Windows terminal for Telnet, and they were using the scrollback buffer for file transfer. But when they got to know that there's like this file transfer thing, that was very nice for them. But this was like pre-2000, so I don't fault them for that kind of mistake. But it was also one of the probably the first time that I realized that engineering is all and good, but communicating with the end users is maybe even more important. That you need to understand the customer problem and really fix that.
Yeah, I mean, in the worst case situation, you would have just increased the buffer size and do what the customer asked without understanding what they're actually wanting to do.
Yeah, that was on the table. That was on the table. That increased the buffer size. We got rid of that limit anyway, but it was not that was not solving the customer's problem.
Yeah.
So the real problem was completely different. It usually is.
Usually is. I have actually one more thing that I like to get your sort of comments or like a little story out of maybe you remember these sort of things. But I feel that there were many summer parties or Christmas parties that just before we were getting ready for the party, there was some sort of security vulnerability that we needed to fix. I think you spent quite a few of those.
Yeah, not maybe. Maybe it's like the few cases that we had that those get like a little bit expanded in the yeah, but yes, we did. For example, I was already on the way for a good party mood in one case, and there was like a Secure Shell 1 vulnerability
That we still fixed.
That we still fixed.
Even though Secure Shell 2 was
but it was it was, but there was a big user base still with Secure Shell 1, and there was a vulnerability out, and then we needed to investigate that is this something that we need to do more.
Yeah.
And then we were out of the party for with Tatu so 1 or 2 hours, and looked at the issue and figured out what we need to do, and drafted some email and back to the party. And then okay, there's been customer cases that those have been maybe this kind of more standard stuff, that there's always somebody somewhere that has some problem.
Yeah.
That isn't changed even with different companies.
But what do you think, what was the fastest turnaround for those sort of vulnerability fixes back in the day?
You mean from
the time we get notified that there's this thing to the time when we release something?
It was fastest, I think, was a day.
Yeah.
So it was we got the notice and then we released a fix. But in the early days, it was basically releasing it was that I did the make dist on my desktop and pushed it to the FTP site. So very simple process. Not much overnight test runs or anything like that. But of course, when we started professionally doing stuff much later. Well, at that point there was no I think that it was me and Lauri Kari who were introducing the concept of continuous integration to the company. So BuildBot was the thing that we put together there, and so after we started really running automated tests and that kind of thing, that then it maybe made it a bit slower because some test suites were longer, but
and also really. In the early days we shipped the source code as
source code.
So it wasn't that we made nowadays we make all the packages on all various different platforms, and it's a completely different beast.
Yeah, so typically it was the AIX and HBUX builds that took the longest because the machinery was bought from eBay.
Really? I didn't know that.
Yeah. The customers the AIX, for example, is a very good example of a system where the operating system manufacturer, which is the Big Blue, is very keen on retaining backwards compatibility, so it doesn't really matter what version you are building it on, because it needs to work on that anyway. But they did have I do remember that, for example, AIX, there's a good support for security features in the platform that was a little bit of pain to implement because it's their own libraries, their own completely own API. So it's okay, for AIX, do we need to do this for AIX? How many customers do we have for AIX? But it was
the big ones.
Many times it was making sense. Yeah. So then you do it. Nice learnings, and I think that we were in the forefront of this kind of thing. So many companies still don't have good CI. So I think that that's for security software especially, it's crucial to have like a good test coverage and continuous integration. Everything needs to go there. I think that if I could go back and improve stuff like for that, I would maybe I would advocate for this software composition analysis tools more. I didn't okay, like they are quite expensive sometimes, these tools, but they may really save like from problems that you get like automatic notification if you have like some library that somebody has introduced by accident or whatever. So the dependency chain is easier to see with this software composition analysis tools, and that is important.
And I think that's going to change now with the NIS2 regulation.
Yeah,
it will
it can
push everybody into more of this thing, which is a good thing.
Yeah,
like sometimes regulation
thing.
is actually a good thing.
Well, it reduces the required amount of thinking about things when you are mandated to do it or required to do it. So then it's very simple. But it's like so this kind of this dependency chains or this supply chain attacks, they are like, of course, very much on the surface because of the geopolitical stuff, and very important to get those cleaned out, because it happens to the largest suppliers, of course, but you don't know when like a smaller operator will be a target, because well, they are looking for any which way they can get. They might be targeting because they know that somebody is getting the software from you, and you are like you're a stepping stone. That's what they're trying to do with this open source project as well. So
that was like, did you go through that Secure Shell related thing? That was really scary. It came like this close with
so like, it was well, the story goes that there was this researcher that on his own time he was investigating that why the database transaction was taking like half a second longer than with this other thing. Maybe plausible, perhaps. Like I know, like I am also like a weird nerd with some things, so maybe that did happen. So, but however, it was discovered, like with like help of some big three-letter agencies or not. But anyways, it was discovered, and the chain of the attack was very interesting anyway.
Yeah. So and the thing that it attacked like the RSA keys that are so prevalently around, and the idea that if it had gone into actual production or distributions that were not like, they were in some beta versions of the distributions, it didn't make into any of the things that anybody
it was in Kali Linux. Kali Rolling had that. Version.
It didn't go. I don't think it went into the production distributions.
No,
so it got caught in
it was in it was in Debian Seed and Kali Rolling.
Yeah. And before then, it was like, if it had gone through, we probably would have not noticed it or got rid of that issue until we transitioned to the post-quantum cryptographic signature algorithms at some point. Like those RSA style things would have been used still for years and years. Like probably I don't know, what do you think? Would it been caught on, like, obviously if somebody got breached and it was investigated thoroughly and they got caught, but they were pretty good at hiding their tracks on.
Yeah, so it was partly a supply chain thing. So it was attacking. There was this
compression library.
The compression library that was linked to systemd, and systemd was handling the SSH first step of the connection, and then you needed like a couple of other preconditions. So it was doing this like check in the beginning. That was the slowing down thing, but it was the attack itself was like against the like CI infrastructure of these different things. So the like built software, like that's like how do you hide that kind of thing? We were talking with it was like in the when I started at Innopoly, we already had like discussions that like with Tatu, for example, that how do we ensure the supply chain in that sense that if somebody has made a malicious version of the compiler, we have no recourse really. So you need to secure the environment at all stages, and this attack was against basically the compression library test suite included that malicious stuff there. So when you did a make, I guess that it's like a make install from that compression library distribution, you got this nice gift of added bonus. And well, I don't think that any algorithms will save from that. That's because you can hide whatever you want like that. So it's going to be like constant battle. So it is not something that has a technological solution in that sense.
Yeah. But I'm thinking like from the point of view that at that point when it did the calls to the RSA related things, then that you might notice that you shouldn't be doing that anymore if you're moved on to use different algorithms.
Well, you'd have to like basically nuke. Well, it wouldn't help because you can just do the whatever you want in software. You don't need the cryptographic library. I don't think that attack vector was using any cryptographic library there. They were like implementing it then the attack.
I understood that there was like this sort of master key that he had embedded into those testing things. So it was like,
well, it was
it was linked to a private key that the attacker
had. And they proved that if you have a certain private key, you can use that to log in. But you could use elliptic curves, or you could use the like whatever future post-quantum fast algorithm you want. Like or they could have had like a pre-step of some knocking functionality there that would have eliminated that delay. Unfortunately, it is quite easy to get rid of that also. So it was like the attackers, they weren't like smart enough to test for performance that well. So they were like happy with this little delay that they had put in there. If they hadn't put that delay, it could have gone like much farther. So just like having 32-bit some like magic cookie in front and then start doing stuff would have eliminated that little hump in the road. And at least like this communicated way of how this was noticed, that would have gone away. But basically you don't get like no algorithm is going to solve that problem, because you can just like roll them into the test suite these completely random test binaries that we are using here, that they were using. The attack was in the compression test cases, and it was obfuscated with these dozen different operations that the test library test suite was doing. So you couldn't see the final the uncompressed attack that it was doing until you really started looking at what the test suite was actually doing. So it was that was included in some kind of it was bug report that this test case like looks for this corner condition or whatever, and like normal looking stuff.
Yeah.
But when you look at the commit, like what is this thing that introduces this kind of like a really surprising looking test case, but it's like you can like the compression library is very nice for that, because like you expect that in the test cases there's like compressed stuff.
Yeah.
So in that sense, nothing surprising. But the surprising thing is that you cannot really look into those compressed things, because they are like behind like 4 layers of obfuscation, because it was like cutting and gluing things together in the test case, and then in the final stuff it was patching the product.
And there was also like surprising in that attack, like the meticulous thing, that how it started, like from the planning, like the social engineering aspects of it, everything. Like
Yeah, the
it was
technical.
like, it was not like just somebody decided that I'm going to do this over the weekend. This was like a multi-month
Yeah, the
year
technical side is almost boring in that sense, that it's like pretty much garden variety obfuscation stuff that is happening there. Actually what you need to guard against is this the whole social engineering stuff, and they do like this kind of attackers. They do employ psychologists and so on. So it is very likely that the attacker was a nation state actor, and probably Russia, and so it's they have all the resources that they like a
and
good
all the time,
yeah,
and
good.
they can be patient.
Yes, well,
Yeah,
that's the thing with what is it? Advanced persistent threat actors. Like they don't care, because they don't need to sell the product to anybody in that sense. They get the they have the motivation and the funding to do whatever they need to do, and they keep at it. If you're a target, you are in a bad place. Nothing that you just need to be like prepared for that. But yeah, unfortunately no silver bullets there either. So it's like just need to. It's more like a process thing. It's not. Again, it's not technological. You cannot really you can. Well, I guess somebody would sell some AI shit here, but I don't believe that it will help. It's like you can. It's like we need like support for the open source people and funding for them, and to get rid of the stress things there. But I don't see that as a silver bullet either. It will help, but it won't remove the problem. So I suspect that we have quite a few of these kind of similar goose eggs hidden all over the place by various actors, and we just need to hope that these different competing people are raising these as problems, so that we can fix them in the community. But so unfortunately, the attack surface is so large that you cannot just get rid of it like that. But of course, if you build everything from scratch yourself, then you can be more confident that there is not this kind of attack, but then you have completely different set of problems, like rolling your own crypto. It's not a good idea for most anybody. Luckily, we did it quite well.
Yeah, well, we sold the OEM toolkits to everybody else, so so if we messed up, then everybody else messed up as well.
Yeah, so that was like helpful at that point. But then the open source stuff was not really there at that point. But nowadays there's very good libraries to base the stuff on. But need to keep a close eye on those, and always remember that stuff needs to have like a hopefully more than one maintainer and like a strong community support and good processes before you include that kind of any package to the dependency chain, because the smaller the component you are including, the more risk there is that it will be hijacked for whatever purpose. So it's like
and like in this particular case, it was a great tool from the beginning. It wasn't like that it was introduced as a malicious thing and somebody accidentally, so it might have been like very well at some point, but it just over the years and the maintenance cycle,
it was
people were able to infiltrate the.
Well, there was like this they were like putting like this kind of fake pressure on the maintainer, so there was like this churn of those forum posts and others that were like pressuring the maintainer to step aside, and then there was this guy, this very helpful guy, and the savior that was taking this kind of problems out of the original maintainer's hands. So it's like it's very, very devious, very very hard to guard against, especially if you're a single person that does it in the free time. It's not something that is very, very easy to just handle. So that's the biggest problem I see these days, that the supply chain is like a very juicy target, and everybody is including packages from everybody. And that's like going to get worse before it gets better. So now it's we are in this like phase where everybody is vibe coding everything, and like who knows what gets included there. So all the more reason to be very careful of what you include there. So these kind of AI like attacks that you use AI to do your software, and the AI is like pulling from thin air these package names that it wants to include because they sound plausible, and then the attacker may have influenced the AI with like this kind of search engine optimization type of ways, and then they can like pre-register those packages that the AI will maybe introduce to the like code, and then none the wiser it works because the package is there and does seemingly what it should be doing, because the code has been taken from elsewhere, just registered under a new name with a little bit of extra, and then you take that into use, and then your system is mining Bitcoin or whatever, Monero, what is the current rate these days. But anyways, that like very risky to give all control to the AI controlled code generation, in my opinion.